Dash. Okay.
Okay, so Git is recording. Are you already? Have you started recording or no? Oh, okay.
Can you guys see the screen right now? Yes, no, maybe so.
Okay, great. I see yeses.
Okay. Direct session. And apparently RS has some beef with triangles and circles.
Okay, I think people issues are getting fixed. So
Kido. So let's start with the basics, shall we? Direct relationships.
okay, you do that. I will. If you want me to do like try and explain something, I can try, but I am so unprepared. You have no idea.
You've been doing this with me 3 times, creative, if not more. You definitely know what you're talking about.
That's not the. That's like I have no idea what's in the syllabus or not anymore. Like if you want me to try and take something, I can.
But in case you're one of those people who have stick around for way too long, you may have noticed that this year's questions are very different from last time. And yeah, so I knew this one should be a bit more exciting.
Okay. Anyway,
I don't know if
I'll
I would like a recap of the basics. Oh, yeah, sorry. Go ahead.
I said I'm just gonna mute now and look in. I'll just pay attention to chat for questions, and then you can do your thing.
Yeah, I'm gonna write with white. Come on. All right. So, should we go over the basics of trig relationships, or you guys know what to do? By this I mean the sine rule, the cosine rule, area of a triangle. There's some stuff like, I don't know, bearings. Yeah, we'll definitely spend a lot of time on that. Some trigonometry, and so on. I know, right? Creative, perfect reaction there. So, no way, still in it. Oh, it is still in the syllabus, unfortunately. I know. All right. So, since some of you, text like, all right. Let's start with right angle trigonometry. Right angle triangle trigonometry. So, you should have seen this before, at least by now. We have a right triangle. So, first off, recap of Pythagorean theorem. A squared plus b squared equals c squared. That's our starting point for trigonometry. First thing first. From there, probably in grade 9 or 10, you guys start talking about trigonometry. So this guy would tell you the Pythagorean relationships would tell you the length. The trig would start giving you a sense of the angle you have in that triangle. So, right triangle trigonometry. That's basically going back to the SOHCAHTOA. So, sine of an angle, sine of theta in this case, is going to be the opposite side over the hypotenuse. Opposite of the angle theta, that's AC, hypotenuse, BC. Similarly, cosine, that's going to be adjacent over hypotenuse, or AB over BC. And tan of theta, that's going to be the opposite over adjacent, aka opposite AC over adjacent AB. All right, that's kindergarten. Moving out. I swear to God, it's not even my phone. Anyway, we just have the noise insulation here is definitely not the best. So we have Pythagorean identity, we have right angle trigonometry. Then move on to, how about we go beyond? How about we go beyond a right triangle? Any triangle. Now we talk about the sine rule, cosine rule, area of a triangle. I'm just gonna quickly brush up on the conventions here. So this length of the side opposite angle A, we denote it as small a, lowercase a. The side opposite angle B, we denote it with lowercase b. And likewise, sine rule basically saying that sine of angle A over the opposite side, small a, is equal to sine of B over B equals sine of C over lowercase c. The cosine rule basically says, all right, if you're given two sides and an angle between the two sides, you can find the other side. If we take angle A, for example, A squared is equal to B squared plus C squared minus 2BC cosine of the angle between the two sides you're given. This is important. Angle between the two sides. Squeezed between the two sides. Area of a triangle. That's going to be a half times the two sides times the sine of the angle between the two sides. That's pretty much it. All right, I should stop reading the chat. And creative, please speak up if you see any question. Right.
There haven't been any yet, but I will let you know.
Yeah, because so far we've been covering like kindergarten content. And yes, you may have noticed I use the word kindergarten a lot because it is kindergarten. So let's have a look at question 1 in section 1. So to be consistent, I'll be writing 1.1, aka section 1, question 1 from here on out. And this is a very interesting question because it's less complicated. It is a proof of intimidation. You look at it, you're like, what the hell do I do? So I shall give you a bit of time to have a look at it. and maybe even have a go at it.
Andrew, are you saying
Yeah.
anything?
No, I was going silent.
Okay, because you suddenly stop speaking and your screen is also okay.
I'm giving you guys space to read in silence.
Oh wait, so this is question one, part one, question one on the first pin.
Yes.
Yeah. Okay, wait. I can put the. I can just take a screenshot of it and post it. That might be helpful. Can you pin things within? You can't pin things within it. Okay, what I'll do is I'll post it here and in the channel. So
Right, yeah.
you guys can continue talking in the stage channel chat, but the Math A channel will have the latest question posted by me.
HL, no, I don't. You guys should know enough to tackle this question. More like, how would you go about solving this big fat question, which can totally be a section B question on paper 2?
So yeah, I guess what you guys can write out in the chat now is what approach you would take to solving the questions. Like, don't crunch out the computations, but say like what trig rules you might use, etc.
Hold on, I'm gonna take the screenshot real quick. Where is it? There we go. Going back. Nah. All right. So this question has two parts. One, find the cost for Mr. McGregor to lay turf on the whole area and to lay sprinkler hoses of the correct length. The second part seems to be a lot easier than the first part because all you need to know is the length of AC and the length of AE. How do we find AC and AE? Cosine rule. Perfect. So, what do we know is cosine rule? We have two sides, and we have the angle between them. Similarly, we have AF, we have FE, and we have angle AFE. Cosine rule, one shot.
Andrew,
Good to go.
uh,
Yes.
we have AB and BC.
A, B, and B, C. Yes. Thank you. So that's the easy part. The harder part, what is the area of this big boy? Is BC 3.3? Yes. How do we want to divvy it up? Thoughts? Simplest way I could think of: total area. That's the area of ABC plus the area of AEF plus the area of ACE plus the area of OCE. Remove the area of the sector OCD. The triangle, the area of ABC, that's kindergarten, because we have two sides and an angle between them. You might as well take a shot whenever I say kindergarten. The area of AEF, same logic.
Don't kill them, Andrew. Jesus.
Oh yes, I'm sorry. Why am I advertising this for underage users? ACE. Now that's a lot harder. How we go about ACE? We know BO and OEO is socialist. No, how you know that? It is not written anywhere. OC is a sector, so OC is equal to OD. That doesn't mean that OB is equal to OE. A proof by staring would tell you that.
You did not just say proof by staring.
Yes.
What is wrong with you?
Once you have AE and AC, you can find CE using the cosine rule and use the cosine rule to find the angle. On the right track. So we have AC and CE from above, right? Sine rule now can be used to find BAC and FAE. We also know the total value. We also know the angle BAF. So subtracting them would give you CAE. So that would give you the area of ACE. The area of OCE sounds like, yeah, we probably need cosine rule here. So this guy, cosine, that would give you CE. Is there a quicker way to do this? Because I'm really not a fan of using the sine rule to get that angle and the sine rule again to get that angle. But hey, if you're stuck on the exam, at least some makes better than nothing. So recap: ACE. ACE, you can get it from calculating the area of ACE. That's basically a half AC times AE times the angle between them. Sine of CAE. CAE, you can get it from 113 minus BAC minus FAE. How do you get BAC and FAE? Sine rule. Getting the area of OCE, what you can do is, it sounds simpler. Yeah. You know what C is. You know what OC is. You know the angle COE. SOCE. You know what CE is. You know what CO is. You know what COE is. Therefore, you can calculate CEO. Therefore, you can calculate OCE. And now you can just plug into your formula. Lastly, area of a sector OCD. Well, now it's kindergarten. So 68 over 360 times pi times 4.2 squared. So crossing off numbers will give you a final answer. So this is taken from a New Zealand internal exam. So in theory, you would get an hour and a half, maybe 2 hours to solve this entire question. How to weigh the angle? All right, maybe I should annotate it on, yes, you got 2 hours to do this entire question. I'm going to annotate this again on the diagram. So consider triangle ABC. We know AB, we know BC, we know the angle ABC. This guy, angle BAC, can be calculated. Likewise, consider triangle AFE. We have AF, we have FE, we know the angle AFE. Sine rule would allow us to calculate the angle between them. No, sorry, calculate the angle EAF. All three of them added, all three of them combined is 113. So that would give you the middle guy. That's all well and good. So you have AC, you have C, you have AE, you know the angle between them. That's it. 3 triangles done. This guy ready to go, that guy ready to go, this good to go. Question, what is area of this triangle down here? Well, you know what AC is, you know AE, you know the angle between them. Cosine rule, bang, CE. You know CE, and you know the angle opposite it. You also know the length of OC. That allows you to use the sine rule to calculate this guy. Sine rule. You know the sum of the sum of the angles and triangles, 180. Minus 68 minus CEO, that would give you OCE. And then you can find the area of this triangle because you know CE, you know OC, and you know the angle. So add it all up, that would give you, and then subtract the area of a sector, that would give you the area of the entire big boy. Questions? To find the area of all triangles and not the one. No, we have to find all 4 triangles, right? But the triangle in the middle, CAE, that can be readily found because you calculated the lengths of AC and AE in the first part when calculating the sprinkler hoses. All right. What do you mean by that? I'm gonna write it out then. You cannot see shit. All right. So this guy, consider triangle ABC. You already calculated AC. So sine of ABC over AC, that's equal to sine of BAC over BC. That's it. Similarly for angle FAE, sine of AFE over AE equals sine of EAF over EF. I endorse the rule set that Creative post. The Creative posted. Rule gifting. So that's question 1 for y'all. And I guess you can see why we did not crunch through all the numbers. 1.2. Ah. Creative, can you take the screenshot of 1.2, please? Pretty please.
Yeah, just give me like 2 seconds.
Thank you. No, that's not. Wait. Oh. Yeah, I think it will be easier for me to just annotate straight on this instead of me trying to resketch all of this.
I pasted it now. It's
Yep.
part 1, question 2, right?
Of course it's accurate.
Look, I don't want to assume lexicographic question going through, you know. This looks fun.
Yeah. And work out the angle APC that they put it there.
Oh wow, it goes to the next page. Jeez.
Yeah, I know. I'm so sorry.
That's okay. Wait, let me do the screenshots again.
I tried to make the image a bit smaller, but it's not small enough apparently. So there you go. Gotta
Yeah,
deal with it.
okay. Let's just paste it.
So
right.
there you have it. All right. What's our game plan? What's our game plan here? Finding AC is easy. All right, good. That's one part of the problem. I wouldn't recommend that. Mm-hmm. All right. Love teamwork here. All right, sounds like we all know what to do. So, to find angle APC.
Well, how do you guys find AP? You guys have found AC and PC. AP still left. How do you do that?
PC. How should I write it?
How should you write what?
We need AP, we need AC, and we need PC. AC, as self you pointed out, is just gonna be Pythagorean. Square root of AP squared plus BC squared. Same deal for PC. CG squared GP squared. AP. What is the total length of, wait, HG40? We know it is a rectangular prism. In the UK, they call it a cuboid. I don't know why they call it a cuboid. It sounds cute? Question mark?
Hey, cuboid sounds cool.
But AB is equal to CD is congruent to GH is congruent to EF. So all four of them are 40. That's very useful information for us. HP over PG is 3 over 7. This is classic GCSE question here. They love towering ratios in weird places. So all of them is 40. HP is 3 parts, PG is 7 parts. So HP is going to be 12 and PG is going to be 28. How do we calculate AP? Well, allow me to introduce perpendicular lines. So let's just call point M out of nowhere. M is directly below P. Because of that, and M lies on CD, therefore MP is also going to be 20. AP now goes back to AM squared plus MP squared. AM squared, again, pi back. So that's going to be AD squared plus DM squared. So that would give you the final answer. So, quick math time. We know that AD is 9. We know DM is 12. So AM, that's going to be square root of 9 squared plus 12 squared. That's going to be 15. AP is the square root of 15 squared plus 20 squared, famously known as 25. One guy, done. AC, we know that's going to be root of 40 squared plus 9 squared, or 41. PC, we know that's going to be a root of 20 squared plus 28 squared, which is, hold up. Yeah, unfortunately, this one is a bit ugly. 34.4. And yes, then we're going to use the cosine rule. So the side opposite angle APC, that's going to be AC squared. That's going to be AC. So AC squared equal to BAP squared plus PC squared minus 2 times AP times PC times the angle, cosine angle between them. Crunching numbers would give you 85.57. Oh, sorry, 85.75 degrees. Of course, there are a lot of ways to go about this question. This is just one of the possible ways. Any questions? Bearings. Quick recap. Personally, I don't know why people struggle with bearings so much. Because all you need to know is that bearing measures from the tippity top going clockwise. So in this case, theta degrees is the bearing of B from A. So let's read the actual question. Two ships leave port P at the same time. Ship W sails 70 kilometers on a bearing 030 degrees to reach point alpha. Where is alpha? There, 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 or there, approximately. All right, I saw some A1. I see some A1. More A1. Perfect, it's A1. All right, second question. Ship W sails 140 kilometers on a bearing of 120 degrees to reach point beta. Where is beta? First quadrant, second quadrant, third quadrant, or last or fourth quadrant? Fourth, correct. This one should be a lot longer. And we know this entire angle is 120. Let's call this beta. 130 degrees from which point? We are talking 100 degrees from the north going clockwise.
Guys, just keep in mind, because I saw some of you write second quadrant. Quadrants go around counterclockwise, but the angle of a bearing goes around clockwise. So that's why it landed in the fourth quadrant, even though it's less than 180 degrees.
Yep. We also know PA is 70, and we know PB is 140. All right. What is the bearing? Hold up. What is the bearing of alpha from beta? What is the angle we're talking about here? I love multiple choice, so I'm going to give you more options. 1, 2, 3, 4, or 5. Which one is it? Be very careful with the wording. For those of you who said 4. Oh. Where is it? There we go. Bearing of A from B. So we start from B, and we go all the way to BA. This angle over there. Oh, yes, please. All right. How do we find this angle? Your life can be a lot easier if you actually notice this. What's the angle APP? 90. That is basically 120 minus 30. That means we have the right triangle. That means the way I'm going to do this, there are a lot of ways you can go about calculating this angle, right? What I would do is extend this guy. Let's call this, I don't know, X. So, angle, the bearing is therefore 180 plus ABX. Now, angle ABX is made up of two parts. We have ABP and we have PBX plus 180. That's going to be the bearing. ABP, that is simply arctan of 1 over 2. PBX, that's going to be 120 degrees. Why is that the case? The angle PBX is 120 degrees. Why is that the case? Not the angles of parallel lines. PBX is equal to NPB, outer angles, plus 180. So that should give you the grand total of 326.56, or you can say on a bearing of 327 degrees. And we do this because apparently people mess up trigonometry a lot, and especially bearings. Like if bearings show up, it can. I can guarantee that probably 30 to 50% of a cohort wouldn't be able to answer. Arc10 is an annotation for tan of 10 minus 1. Sorry about that. I tend to write Arc10. It looks a bit nicer and not as confusing. Because I'm gonna kill you if you write something like this. So yes, I prefer inverse tan. I prefer writing Arc10 instead of whatever. So that's that. Any questions? Moving on to question 3. No, sorry, question 4. Beautiful IGCSE question. (360 minus angle 5), that works as well. But how do you calculate angle 5? Uh, I don't think so. And yes, actually, for the math has a lot of good questions. I recommend. All right, what's our game plan? That is a valid strategy for sure. That's a hint. All right. Time for our favorite tool in math, symmetry. Let's set the R over there. We can divide it into two R's. We can split it into R1 and R2. Because of symmetry, they are equal. That means we just need to find R. That's what we just need to find one of the two areas. Let's just use R2 because no comments. How do we find R2? I'm gonna spare you guys the picture. Just gonna quickly sketch this guy. O1, A, B, and O2. This is R2. And when you see it like this, I think you guys could all have a stab at it. Correct. That's gonna be area of a sector minus the area of a triangle. That means we will get a half. No, sorry. We will get AO1B, sorry, over 360 times pi r squared, which is 6 squared, minus a half times 6 squared times sine of AO1B. What is AO1B? How big is this angle? Yes, saying AO1B is a semicircle will get you 1 of 7 right off the bat. I'm going to add one more line. Connecting the centers. A01, 6. A02, 6. What's O1, O2? 6. Because O2 lies on the circumference of the circle with center O1. O1b, 6. O2b, 6. They're all 6s. That means we have
Wait,
an equilateral triangle. Yes.
Oh, I wanted to do a poll. Okay, never mind.
Sorry, grade F. Yeah, so we have 60 here. We have 60 there. In total, we have 120. So angle A1B is going to be 120. So you're going to plug back in, and there you have it. Don't worry, creative. We're going to have fun when we get to 1.2, when we get to section 2 and 3. There's a lot of fun over there. Are we confident with trig ratios? Or should we skip 5 and go straight to 6 and go straight to 1.2? All right, maybe we should do it then. Without the calculator, we find the value of each trig ratio. And because I have a mild OCD, I'm going to align the two numbers. So, yeah, split in them. All right, charge accepted. Sin 5 pi over 6. What's that?
Wait, do you want me to do a poll?
Yes, yes, please. I'm about to ask you to do that. Yeah, this is a perfect time for polling.
What options do I put? Maybe I'll just put the regular, like, okay, hold on. I'll figure this out.
Is it a table you need to memorize? No. You shouldn't have to memorize anything, honestly, apart from the first quadrant. But that requires you to know your shit, so.
I'm assuming it's one of those. I haven't actually figured it out yet.
I would have added some negative options.
Oh, is it? Yeah, I can't be bothered.
That's a math. When in doubt, sketch the thing out. Nope. Up, down, back up. 0, 180. We have 150. Sine of 150 is equal to sine of 30. Or a half. Yes, I recommend. So what Rishi was saying is that there's a way to memorize the exact trig ratios in the first quadrant. So sine, cos, and tan of theta. 0, 30 degrees, 45, 60, 90. We start with 0, 1, 2, 3, 4. No, sorry. My bad. So for sine, we start with 0, 1, 2, 3, 4. Take the square root, divide by 2. For cos is opposite. Yes. So 4, 3, 2, 1, 0. Take the square root. Divide by 2. Tan is sine of a cos, so I wouldn't bother memorizing them. Isn't the unit circle better to do in exams? Yes. But if you just wanted a quick and dirty way to get your answer, this would be it. B. Cos of negative 135. That's going to be cos of 135. That's going to be negative cos of 45. That will be negative root 2 over 2. I know I'm going very fast here. So cos of negative 135, that should be all around here. Because of symmetry, cos of negative 135 is equal to cos of, cos of negative 135 is equal to cos of 135. Cos of 135 is negative cos of 45. You can also use a unit circle. Different ways for different folks. If you are a fan of unit circle, please feel free. Go ahead and use it. We have cos of negative 135. Reflected. They're equal because they have the same x coordinate. Reflected again over the y-axis. So just have to trace your way back. Cos of 35, cos of 45, that's root 2 over 2. Therefore, cos of 135, because you're reflecting over here, this part is going to be negative root 2 over 2. Cos of negative 135, that's the same thing as cos of 135. Same x coordinate, negative root 2 over 2. C. Tan of negative 8 pi over 3. Creative. Have you found your newest favorite pastime?
Wait, the answer is one of the options, right? I didn't actually check this.
Well, we're about to find out.
Okay. Okay, good. Oh, this is so scummed. I'm having fun making the polls, though.
All right. Interesting to see a relatively equal split there. What's the period of 10x? Pi. That means that the function repeats itself every pi radians. That means that tan of negative 8 pi over 3 is equal to tan of pi over 3, which is famously known as root 3. This is a foreshadow to what's to come. I totally gotta make new axes. So pi over 2, negative pi over 2, negative 3 pi over 2, negative 5 pi over 2, negative 7 pi over 2. Shoop. 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 Negative 8 pi over 3. Where is it? Somewhere. Wait, 8 over 3, that's 2/6. That should be somewhere over there. Because the function repeats of every pi radian, this point is equal to that point, equal to that point, equal to that point over there. So it should be pi over, it should be root 3. Negative 8 pi over 3, and negative 5 pi over 3, negative 2 pi over 3, and then pi over 3. You cannot re-explain your circle for tan unless you do sine over cos. So that would be a bit more complicated. But in terms of a unit circle, that would be going around the circle. So you have the angle negative 8 pi over 3. Negative 8 pi over 3, that's what? Negative 8 pi over 3, that should be negative 2 pi over 3. So somewhere over there. Negative 8 pi over 3. That means you start from, yeah.
Wait. Can I explain something quickly? So you can think of tan using the unit circle. The geometric interpretation of tan would be the slope of the angle. So
oh, yeah, true. Yeah.
So if you imagine going around negative 8 pi over 3 degrees, right? So, or equivalently, because it cycles every 2 pi, right? So that's the same thing as what? As negative 2 pi over 3, right?
Yeah. So basically, you start from 0. You go clockwise because you're going in the negative direction.
So you landed the angle negative 2 pi over 3, which just by eye you can see it'll have the same slope as the angle that's 180 degrees across from it, which is the angle pi over 3. And tan of pi over 3 is, well, I mean, that's one of the values you have memorized, right? So that you can get that's square root of 3.
I'm going to make it green.
And see.
Thank you, creative. So
no problem. Yes, I mean it's kind of, you remember how slope is defined as rise over run, right? And tan is sine of cos. So that's kind of how the relation works. Do I make a poll for question D?
Sure.
Okay.
Which one am I do though? I don't think, because I think we're going a bit too slow.
Okay. We could do something like one of G or H if you really want.
Do you want to?
I think it would be instructive, and then we can move on.
Yeah. No. There. M23 had a question that uses G or H. I'm pretty sure. Yeah. All right. So let's do H then. Where does the 3 pi come from? Because that will give you an angle that you can work with. Because you should know all the angles in the first quadrant. So between 0 and pi over 2. Sometimes, all right, you might want to stretch a bit and do negative pi over 2 to pi over 2, but still. So negative 8 pi over 3 plus 3 pi, it will give you pi over 3. And you should know the value of pi of tan of pi over 3. When creative is preparing the poll, we shall do. Is it up? All right. We shall do E. Cos 10 pi over 3.
Wait. Am I making a poll for part?
No,
two
you're
or
making
part...
a poll for H, but while
Oh,
waiting
okay,
for you
okay.
to make the poll,
Okay, got it.
let's do E. Cos of 10 pi over 3. Yes. Is my handwriting that bad?
Okay, well, I put the poll up.
No, it's not a wrong question. I was thinking of doing this question in the meantime. So, cos 10 pi over 3. Period of cosine is 2 pi, so that's basically cos of 4 pi over 3. Cos of 4 pi over 3, sketch it out. 4 pi over 3 is equal to cos of 2 pi over 3. And cos of 2 pi over 3, that's equal to negative cos of pi over 3. And cos of pi over 3 is a half. So final answer, negative a half. G and H are more interesting. But for the sake of time, we're just going to do, can you do it again? Absolutely. So, cos of 10 pi over 3 is equal to cos of 4 pi over 3. Why? You are subtracting 2 pi, aka the entire period. Aka you are at the same point as before. If I am to extend this guy, 10 pi over 3, that's basically over there. That's 10 pi over 3. This point is equal to that point. You're going around a unit circle, or you're hopping along the curve. So 10 pi over 3 is 4 pi over 3. Because there's a line symmetry here, 4 pi over 3, that's basically cosine of 2 pi over 3. And cosine of 2 pi over 3, that's negative cosine of pi over 3. And cos of pi over 3, that's a half. Final answer, negative a half. Yep. Correct. Oh, yes, we missed that. Yeah. Unfortunately, we're using beta technology now, Matt, so that you don't get to see a lot of very beautiful MS Paint action. All right, G and H. H is a bit more interesting. All right, I'm going to take a look at the poll real quick. How did you get 0? Explain the reasoning. Yes. And you. I love your roast, creative. Let's sketch it out, shall we? Pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. It is an odd multiple of pi over 2. Notice what happens to the odd multiples of pi over 2. Zero. All right. Any questions? Yes, I was referring to that. M23, I don't remember which time zone. There was a question that started off with the integral of cosine of root x. Honestly, I think that question is stupid. Because that is I swear my uni students would struggle with that. Hey, if you know your stuff is fun, and actually quite testing. All right. Moving on to trig functions, y'all. Yeah, I prefer creative notation because an odd integer can be negative. All right. Creative, this is your chance to shine.
I'm sorry, what?
We are moving on to section 2.
I haven't read the question yet.
And question 1 is a series of multiple choice.
Oh, for the polls. Oh, yes. Okay, good. Oh, this is wonderful because I can literally just copy. Okay, nice. I'm not gonna write out the question though. I'm just gonna do like 1A. Oh, this is great. I don't even have to think. I don't have to solve the question before posting it.
Yeah, probably not the best question written in hindsight. Not a best option in hindsight. Okay. Oh, and if you're not M24 and you're confused, that's totally understandable because I just brought up the question about M23 and that seems to be a bit too testing for most students. So that's not to do with trigonometry right now. But it definitely uses the same concept that we have seen in section 1, section 5H. All right, so what do we get in the post? All right, the period is. So, quick recap. A sine of bx plus c plus d, or y equals a cosine of bx plus c plus d. The magnitude, we'll talk about later. The period, that's going to be 2 pi over the absolute value of b. Think of it as a horizontal compression or stretch. If the natural frequency would be 2 pi, but if you have sine of 2x, you're moving twice as fast. So now the period is pi because you go faster. So 2.1.1, final answer is B, because the period is 2 pi over pi or 2. 2.1.2.
Oh, wait, is that my cue?
Yes.
Okay, right. And what is this? Oh, 2.1b. Okay.
Oh, yeah, sorry.
I'll write 2.1b. I don't know why I didn't write that before. 84 to negative. What are these options? Okay, posted.
Sweet. So, all right. Waiting to see. I'm waiting for more responses. Going once. Going twice. Going thrice. All right. 10. What's the maximum value of a tangent function, people? Let's sketch this guy. Let's just start with y equals tan of x. Oopsie. Going straight to infinity. So if you translate it, well, it's still going to infinity. If multiply by 3, it's still going to infinity. If you add 1, it's still going to infinity. Final answer, infinity. Or option 1. C. This one should be quick.
Oh, right. Okay. Never been prepared for this. Okay. Options are 3, 2, negative 1, negative 3. I wish that like why is the minimum time I can allocate for a poll 1 hour? Really should make it like 5 minutes or something, but there's no option for that.
And we finish up to yeah. In case you couldn't tell, we are not known for speed. Happy to see that no one put negative amplitude. So the amplitude for not magnitude, my bad. So the amplitude for these functions is the absolute value of a. All right, bang, bang. That's 2. Service time, the midline is gonna be D. So those are the 3 key things for you to keep in mind when you have adjoint functions. Amplitude, that's the absolute value of the stuff coming before sine the constant, before sine the cos. Period, that's 2 pi over the absolute value of B. Midline, that's gonna be D. Maybe we should skip 2 and go straight to 3. That's gonna be a bit like quicker, quicker, punchier. 3. Maximum and minimum values. Right, go, go, go. Max, min, A, B, C, D, E, F, G, H, I, J, K, L. If you remember only one thing from this session, these are without calculator. This is the stuff I do with students, grade of. Come on. All right. If there's one thing you take away from this session, sine and cos is always bounded from -1 to 1. And I'm going to write blah because it doesn't matter what you put inside that blah. So, yes, just quick fire. This one shouldn't take long. 3a, what's the maximum? Maybe I should do one together. Yeah, maybe that's a good idea. So, 5 minus 2 sine of 3x minus pi. All right. We know that sine of whatever the fuck is that this guy, it's gonna be between -1 and 1 times 2 times negative 1. Plus 5. Minimum 3, maximum 7. Three B. What's the max? What's the min? And what else? Three 7. Yes. What's the part? C. What's the max? What's the min? Good. They're all the same. Changing the period doesn't change shit. It doesn't change anything, right? End of the day, you just make it go faster or slower, but you're not stretching it vertically. Same answer. D. 95. E. All right. F. Is it the same? Is it not the same? Should it be the same? It should be the same. G. Yeah, you're smashing it. G is now a test to see if you've memorized or you actually understand what's going on. Oh, fuck. 7 and 3? You sure 7 and 3? It is 7 and 3. Please wind up working. Yes, I will. So, we found, very conveniently, it's right there. All right. Negative 3 less than or equal to of that mass less than or equal to 7. You're second reciprocal of it. The inequality sign flips. Then times 21. Because you're multiplying by a positive constant, the sign remains as is. Max 7, min 3. H. Good. Still 7 and 3. Correct. Wait, no. Oh, wait, no, I got ahead of myself. Sorry. I. Sure. It is 24. It's 25. 1 over 5 and 3. Maybe I should expand this a bit more. Instead of 5 plus 2 sine of 2x minus pi, I have 2 sine squared of 3x minus pi. Starting with the same inequality. This method is kind of foolproof, by the way. You square it. What you get when you square in this guy? 0 is the new lower bound. It's equal to 1. Add multiply by 2. Add 5. Take the reciprocal. Add 5, it should be 7. Oh, sorry. Less than 1 over 5. Multiply by 21. Min. Max. How about J? It's not the same. So, where are we now? All right. I multiply everything by -2. Then I give you -2 less than or equal to -2 sine squared. 2x minus pi less than or equal to 0. Add 5. Take a reciprocal. Sorry, 1 over 5. Multiply by 21. Seven. 1 over 5. There is a typo for K and L. So I'm going to change the 5 to a 7. So I'm going to write down the questions so that you're not confused. Now it's getting interesting. No. Unfortunately, I don't think that's how it works. All right, let's complete the square for downstairs. The presence of 4 sine 3x minus pi throw everything up proportion. Would it work? I think it will also work. Yeah. No. Wait. I think you guys have a point. I think it would work. Though that would be quite a risky move. Because you got to justify your answer, right? It'll be a bit harder for you to justify. Let's look at downstairs. And we're going to complete the square for this. We know that sine of whatever is always between -1 and 1. Sine minus 1 is going to be divided by -2 and 0. Squaring this give you 4. Multiply by -2 That changes the sign of inequality. Yeah, it's a 7 because a 5 wouldn't work. And now we're going to add 9. To both sides of inequality. Then you take a reciprocal. So maximum 7 over minimum 7 over 3, maximum 21. This is definitely a grade 7 question. Questions or comments? If not, we shall move on. I mean, this is a more systematic way to go about to prove inequalities. But definitely in school you have been taught like the max is gonna be what absolute value of, it's gonna be absolute value of a minus maximum is absolute value of a plus d, minimum is gonna be whatever, right? But it's just a result of use of proving. Like, sorry, you can prove these results readily using the inequality that I just wrote down. Just keep in mind that sign is always between -1 and 1, and cos of whatever is always between -1 and 1. And you should be set. 2 and 4. Trig equations. There was this thing with cos of. All right. Good question. Cos of 90 plus x is equal to sine of x. That would work. You can think of it as a translation, because at the end of the day, the sine curve and the cosine curve, the translations one another. You can literally translate the cosine curve to get sine, or you can translate the sine curve to get cosine.
Andrew.
Yes.
Can you go back to your working for the part before this? I don't think this is correct. Like, wait. What did you get as the lower numbers?
The lower bound 7 over 3.
Did you get an upper bound?
No, I changed it to 7 in the denominator.
Okay.
Because if I kept it at 5, it would blow up. We would get an asymptote.
Oh, right. Okay, I see. Yeah, I didn't see you wrote a 7. Never mind.
Yeah, no, that's a very good point. A.
Gotcha.
I didn't want to do question 2 because it's a bit of a pain. So let's just do 4. Do we want to do 4 or do we want to jump straight to 5? We're at 4. Solve this guy. Oh. You know what? This guy simply you know what? You only need to solve 3 equations separately and put it all together, right? So for the product to be 0, at least one of them have to be 0. So basically, you will have to solve 3 different equations. Start with the first one. Sine of 2x minus pi is equal to 1. This is my excuse. This is my way to make you guys feel like you guys solving fewer equations. But you still get a practice that you need. All right, sine of 2x minus pi equal to 1. How do we solve this? 2x minus pi, that's equal to arc sine of 1 plus k times 2 pi. Arc sine of 1, famously known as pi over 2. So now we get 2x equals 3 pi over 2 plus k times 2 pi. Divide by 2. Et voila. So in the ratio we're given between 0 and pi, we only have one solution, 3 pi over 4. Second equation, and starting here, sometimes you hear me go totally silent. That is on purpose, because there's nothing for me to comment on. This is paper 1. Isolate and solve. This guy, you have 2 options. It's either arc cos of negative a half or negative arc cos of negative a half. When in doubt, sketch the bloody function. You know we're going to have 2 solutions. Because of a line of symmetry over here, if this is a solution, then this is also a solution. If A is a solution, then negative A is also a solution. So we have 2, that's why we have arc cos of negative a half and negative arc cos of negative a half. Arc cos negative a half, that is 1, 2, 3, 3, 2, 1, 2 pi over 3. Multiply by algebra. Now, going back to our domain, x is between 0 and pi. Yeah, I'm afraid you gotta rewatch the video because I shared my way of memorizing exact values in the first quadrant. No, that's totally fine. In this quadrant, what do we get? Pi. And that's it. Because this guy, when you add 2 pi, we get 5 pi over 2 out of range. Negative pi over 3 out of range. Did I mess up this? I did. Ah, that back neck. Okay. Yes, you guys also get a healthy dose of Quebecois squaring. So, subtract pi, that will give you pi over 3. I'm so sorry. Or this guy will get negative pi plus k2 pi. So, look at the roots. Pi over 3, that's definitely in. Add 2 pi, that's going to be 7 pi over 3, that's out. Minus 2 pi, that's going to be negative pi over 3, that's out. Because we're interested in 0, 2 pi. Similarly, this is not the scale, by the way. Similarly, you have negative pi. Then you have pi. Then you have 3 pi. Pi is right on the edge. So pi is included. So this guy has 2 equations. There's 2 solutions. All right. Any questions? Third equation. Tan of 3x plus root 3. Is it a constant for a number of person? Yes. I did not say this explicitly, but this we call this the general solution. In IB, you're not expected to know this, but I just think it's a lot easier for you to wrap your head around compared to other methods like shifting the interval or whatnot. All right, now we have this solution here. Negative pi over 9, add pi over 3, add pi over 3, add pi over 3, add pi over 3, and so on. We're interested between 0 and 2 pi. I'm sorry, and pi. So there are 3 solutions. Therefore, combining all the solutions we have, the first equation yields 3 pi over 4. Second equation yields pi over 3 and pi. Third equation yields 2 pi over 9, 5 pi over 9, and 8 pi over 9. So those are all the solutions. What does k pi mean here? Like, why is it k times pi and not anything else? Correct, that's a period. So, same thing with k times 2 pi. 2 pi is a period of cosine. Same thing with k times 2 pi here. That's a period of sine. Yes. So you are literally moving along the curve, or you're going about the unit circle. Questions? Shall we move on to 5? This is taken from a TMUA exam. I'm pretty sure this is one of the last questions on the paper. And it's a multiple choice test. So you basically have 4 minutes to solve this question. No, we cannot. This is kind of what you guys signed up for. Is it though? All right. Let's solve this together. Honestly, I would love to see this as like the last question or the second last question in section A for paper 1. Very well designed question. So this guy, you have 2 cases. Oh yeah, I didn't tell you if it's in degrees or not. Yeah, no, let's just keep it radian then. Pi times, oh yeah, it should be in range. Sorry, my bad. Pi over 3 plus k2 pi. Or 2 pi over 3 plus k2 pi. One up. Negative 3 pi over 2. It should be 240. Yeah. So negative 4 pi over 2. 4 pi over 3. No, sorry, 4 pi over 3. My bad. Or 5 pi over 3. Moving on. Divide everything by pi over 3. Oh, oops. Oh, sorry. It should be plus 6. This is where the fun's at. How many solutions can exist for this equation? Why is it 3 and not more? No, sorry. Like, how do we move on from this? Where do we go next after this? What is the value of k here? Recall the bounds for cosine of theta. And then you take that and you raise to the power of, you take 4 to that power. This guy has to be between -1 and 4, aka this is very useful information. This guy rejected. Impossible. If k is negative, then we'll start from -5 onwards. Also couldn't work. If at 6 you get 7, that also wouldn't work. So in all cases, k has to be 0. That's the only option. This means that your problem now boils down to 3 equations. 4 to the cosine of theta is equal to 1, 4 to the cos is equal to 2, and 4 to the cos is equal to 4. That means cos of theta is 0, or cos is a half, or cos is 1. If cosine is 0, let's find some solutions. That'll be pi over 2, 3 pi over 2, 5 pi over 2, and so on. Second equation would give you pi over 3, 5 pi over 3, and so on. Last equation would give you 0, 2 pi, 4 pi, and so on. We need to find values a so that the equation has exactly 3 solutions. Be very careful with this. Let's put all of our solutions on a number line. 0, pi over 3, pi over 2, 3 pi over 2 is over here, 2 pi is over there. Do we miss anything? 0 pi. I don't think I missed anything, right? 5 pi over 3, that's way over there. All right. We need to find a so that this guy has exactly 3 solutions. Let's start from the left. 1 solution, 2 solutions, 3 solutions. The minimum value of a, the absolute minimum, has to be pi over 2. If it's less than that, you only have 2 solutions. Oh! Wait. 5 over 3, 5 pi over 3. Yeah, 7 pi over 3. Yeah, sorry, my bad. Now, how far can you go? You can go all the way until you reach the next solution, right? Because if you stop here, there are only 3 solutions. If you stop there, there's still only 3 solutions. If you stop right here, you have 4 solutions. Because we include a therefore cannot be 3 pi over 2. We get very close to 3 pi over 2, but not on 3 pi over 2. So the range of values that you're looking for is pi over 2 inclusive. Wait, no. Inclusive to 3 pi over 2 exclusive. So we include pi over 2 and we exclude 3 pi over 2. And I would say if we can solve this in under 4 minutes, kudos to you. Because a lot of thinking is going on right here. Should we take a break or do we want to carry on? Nope, it's just gonna stay here. Yeah, it sounds like the chat is very silent today. All right, moving on to identities then, people. I'm not gonna prove identity. I'm not gonna prove identities because also you don't really need to know how to prove them. Though it could show up in paper 3, because why not? Oh, this is better. Like usually the half-life for this session is 1 hour. So like we're doing better than expected. Creative, wanna comment on that? Alrighty. So identities. For SL, all we need to know is the double angle formula. So sine of 2x, that's 2 sine cos. Cos of 2x, that's 2 cos squared minus 1 equal to cos squared minus sine squared equals sine squared equals 1 minus 2 sine squared. That's all you need to know. For HL, you have a bit more work. Apart from the double angle identities, you will learn how you got to those identities. So, the compound angle formula, sine of alpha plus beta, sine alpha cos beta, minus sine of beta cos of alpha. Also alpha plus beta, cos of alpha cos beta, minus sine of alpha sine beta. Tan of alpha plus beta, that's going to be tan of alpha plus tan of beta over 1 minus tan alpha tan beta. Then we get to the Pythagorean identities. Sine squared plus cos squared equals to 1. Tan squared plus 1 equals secant squared. And cotangent squared plus 1 equals cosecant squared. And if you don't know your identities, you're done with calculus. Yes, but the problem is, if you have to look at your formula booklet, most likely you're done. Like you should have them literally memorized. And you don't even have to actively memorizing them. Like you should be doing enough equations that these should like go without saying. Anywho, moving on. So 3.1 SL identities. Right. Question 1, proving identities. This shouldn't be too bad. Sine squared minus cosine squared. 1 plus 2 sine cos. Tan x minus 1. Tan x plus 1. What's the game plan? Not really. Like a lot of IB stuff is literally pre-calculus. No. Yeah, no, it's very easy to commit crimes in trigonometry. Very easy. All right, where do we even start? Uh, don't take it out of context, for fuck's sake. All right, either way, this is not looking very friendly. So let's start with the left hand side. Difference of squares at the top. And I'm going to write this guy as sine squared plus what plus cos squared. Reason, we want to simplify things. And if we do as you said, you would get sine of x plus cos of x squared downstairs, which conveniently cancels out the sine x plus cos x upstairs. Multiplying this guy by 1 over cos, or you can say dividing top bottom by 1 over cos. That would spit out your final answer. Questions? Yep, we do 2 sine cos equals sine of 2x. Then we write cos squared of 2x as 1 minus, as 1 minus sine squared. Would that work? Well, I don't know if you can find a way to get it to your final destination. Yeah. So the 2 sine cos basically got swoosh into that squared. All right, part B. What do we have? 4 sine squared over 1 minus cosine squared. Oh, oopsie. 16 cosine squared of alpha over 2. No, this is not a typo. Yes, thank you. Left hand side. Downstairs is sine squared of pi over 2. Oh, I forgot to. Yeah, I forgot to do my signature move. Hold up. So, you've seen that sine of 2x is 2 sine x cos of x. Sine of 2 times blah. It does not matter what you throw into the blah. It's equal to 2 sine of blah cos of blah. This matters, this is the case here, because we're interested to get to pi over 2. Because on the right hand side, we also have pi over 2. So, sine of alpha, that's basically sine of 2 times alpha over 2. This is our blah. And this is equal to 2 times sine of blah cosine of blah. And now it's just kindergarten. And killing people. So that'll be 16 cosine squared of alpha over 2. Or right hand side. Question 2 is arguably the most important question in the entire session. How do you use the double angle formula? Not many shots, but I think it's enough to get you drunk. All right, A. Cos of 2x plus 5 cos x minus 2 is equal to 0. How do we start? We turn cos 2x into something with a square. Good, that's a good start. What's that something? Because we have two things with a square. Yes, we could do that. Why is that the case? Because that would give us the quadratic in terms of cos. That's why we're going to use 2 cos squared of x minus 1 instead of using 1 minus 2 sine squared. Yeah, no, this is something you must know, like, period. I'm not going to go on solving. That's not the important part here. Part B, sine of 2x minus cosine of x. Radiof, stop. No, you're right, and oh yeah, yes, that's it. When you have sine of 2x, you have no option. Your only option, 2 sine cos. You have no choice. That's easy. C. 3 cos 2x plus cos of x equals negative 1. We want to get a quadratic in terms of cosine. So, same strats. D. 5 sine minus 4 equals 2 cos of 2x. This time using the sine one. Correct, because you want to get a quadratic in terms of sine. this guy gives you the quadratic in terms of cos. So 5 sine x minus 4, that's equal to 2 times 1 minus 2 sine squared. And my handwriting is getting progressively worse. 4 sine squared plus 5 sine minus 6 is equal to 0. And so on. E. Ah. That's one twist. Just make everything sine. Why? Look at the sine x term hanging out over there. I didn't explain why we should convert it to sine instead of cosine and whatnot. That's because if you have let's say we have a squared term, it's easier for you to get between sine and cos. But when you have sine to the first power like this, it's very, very, very annoying. So we would, choose the path of least resistance. Just convert everything to sine. F. I think you probably start to notice a pattern here. And again, you get a quadratic in terms of sine. So that's the part of the entire exercise. Just to getting you to think about, should you use 1 minus 2 sine squared? Should you use 2 cos squared minus 1? Or even should you use cos squared minus sine squared? Moving on. 3 or 4. I don't want to do both. We have 2 more for SL and 4 more for HL. No, sorry, two more for SL, then 4 in HL. So like 6 questions in total left. Let's just do 3 for completeness. We are given that tan of 2x is 3 over 4. We are also given that pi over 2 is less than x less than 3 pi over 4. What is cos of 2x? What is cos of x? And what is sine of 4x? Oh yeah, indeed. Some people aren't sleeping tonight. Yes. To have us get a sense of this guy, would this work? Yes and no. Where are you gonna go from there? There we go. Good job, chicken noodle. Tan of 2x is 3 over 4. So if this angle is 2x, the opposite is going to be 3. Adjacent is going to be 4. Hypotenuse is going to be 5. So we know the cos of 2x is going to be 4 over 5. But we don't know if it's positive or negative 4 over 5. How do we know which interval, which sign it would take? Look at the interval you're given. The range you're given is between pi over 2 and 3 pi over 4. pi over 2 less than x less than 3 pi over 4, multiplied by 2, pi less than 2x less than 3 pi over 2. In this interval, a proof by staring will clearly tell that it's going to be negative. So cos of 2x is negative 4 over 5. From there, how do we get to cos of x? All right. So cos is plus or minus 1 over root 10. Is it plus or minus? Why is it minus? Second quadrant. C, sine of 4x. You know that HL trigonometry is mostly SL, right? Sine of 2x. We know the value of cos of 2x from A, spot on, negative 4 over 5. What is sine of 2x? Positive, negative. It would be negative, yes. So, negative 3 over 5 over here. 2 times negative 10, we get 4, that's 24 over 25. So this question can easily show up in the later parts of section A on paper 1. Questions? If not, we shall move on to 4. I'm getting tired, and it's very common in university to see sine of x written as s and cos of x written as c. But of course, if an argument is not x, then you better write the entire thing, otherwise you're confusing yourself. Yes, all right. 2 people are spending. I guess it could work. But you're making life way harder for yourself. Two options. Take it out domain. We know x is between 0 and 2 pi. So we start off with pi over 3. Add 2 pi, you get 7 pi over 3. That's out. 5 pi over 3. We add 2 pi, that's out. Minus 2 pi, that's also out. Pi over 4. You add pi, you get 3 pi over 4. You get another pi, you get 7 pi over 4. You add another pi, you out. So, grand total, 4 solutions. Do we have to write k to pi when you were given about boundary or an interval? I would highly recommend, because that reminds you of the period. Alternatively, I've seen a lot of ways people teach this. You can manipulate. Sometimes you can manipulate the interval. Not in this case, but you can manipulate the interval to make sure you have all the roots, aka like you're using a linear transformation. But I still prefer to use general solution. That will make things a lot clearer. And you guys have access to the notes later on. This is a recap review. Yes. Radif, can you answer the question? Right, right above your message. All right, part B. Like, where are we gonna upload the notes or the recording? Yeah, I could tell. B. This is where things get more interesting. Like, if you've got a sense of part A, you should be able to start part B. And by the way, this is a shameless plug. Go to my website. Because I tend to post very weird questions like this. So, all right. So you know right off the bat, it's gonna be very similar to part 1. So I'm gonna skip some steps. Yeah. So m sine 2x plus cos of 2x minus sine of 2x, that's going to be 0. So you have two options. You have cos of 2x is equal to negative 1 over 2. Or you have m minus 1 sine of 2x plus cos of 2x is equal to 0. We can simply have all the solutions we have found above, because we know the solution to... Wait. Oh, no. Sorry. Spotted a typo. So 2 cos plus 1 is equal to 0. Cos is negative a half. That means this side will be negative pi over 3, or... Hold up. Negative pi over 3? Wait, no. Cos is negative a half. Hold on, why am I having a brain fart right now? 1, 2, 3, 3, 2, 1, 1. All right, 2 pi over 3. Or 4 pi over 3. Where's it? 2 pi. Wait. What am I tripping? Cos of x is a negative half. Negative root. That should be, wait, 1, 3, 2, 1, 1, 2, 3. It should be 2 pi over 3. Yeah. And 4 pi over 3. Yeah, voila. So I'm going to change this answer a bit. 2 pi over 3. Then 4 pi over 3. That means the new solution is going to be pi over 3 and 2 pi over 3. And 4 pi over 3 and 5 pi over 3. But we're only interested in the interval. What's the interval again? 0 to 3 pi over 4. We do not need any other solution. Now, these two equations combined should give you 3 solutions. We have 2 solutions from the first equation. That means this guy should give you another solution. Or, to get 3 solutions total, you would either get, let's say, one solution that's not pi over 3 or 2 pi over 3. Or you get 2 solutions, including one of pi over 3 to pi over 3. Or maybe you get 3 solutions, including both of pi over 3 and 2 pi over 3. I'm just listing out the cases. We'll revisit this when the time comes. So, or you get 4 solutions. No. Anyway, so m minus 1 sine of 2x plus cos of 2x is equal to 0. All right, so isolate and solve. We will get this guy. And we know that this equation had... And then we're going to consider each of the 3 cases. Let's sketch it out. Tan of x will have an asymptote at pi over 2. So tan of 2x will have an asymptote at pi over 4. And then we have another asymptote, not here, at 3 pi over 4. So, going up, going up. What are our options? We know that pi over 3 and 2 pi over 3 are already solutions. That means that we have, let's say, this point over here, that is a solution. Or that point over here, that is also a solution. Hold up. Yeah, that part over here can also be a solution. Wait, 2 pi over 3. Wait, pi over 3. Oh, wait, no. I don't know how to math. Pi over 3 should be somewhere over there. And then 2 pi over 3 should be somewhere over there. There we go. And we want to count the number of intersections between the line and the function. So what are our possibilities? One, if you have one solution that's not pi over 3 or 2 pi over 3, that's not the case here. Let's say, all right, the easiest way to do this is that I'm going to draw a line and I'm going to hover it over the graph. So let's go from the top down. How many solutions do we have here? 2. How many solutions do we have here? 2. How many solutions do we have here? 2. How many solutions do we have here? 1. How many solutions do we have here? 2. How many solutions do we have here? 2. How many solutions do we have here? 1. And going down, 0, back to 1. So if I am to summarize the results, if you're anywhere up there, up to this point over here, you have 2 solutions. That's not pi over 3 or 2 pi over 3. If you're between this point and that point, you have, what do you have? You also have 2 solutions. That's not pi over 3 or 2 pi over 3. That's not good. If you're at this point, you have 2 solutions, including 2 pi over 3. So this is the case we're interested in. What other case are we interested in? Going below this, in this section, you only have 1 solution. Below this point, you also have 1 solution. But at this point right here, you have 1 solution that is pi over 3. AKA, we are also not interested in this area, but we're interested in the one above and the one just below. This question is borderline HL. Like, I don't think I would give this question on SL, but you can solve this using SL content. All right, so case number 1. Negative 1 over m minus 1 is positive. Wait, no, sorry. Case number 1. And negative 1 over m minus 1 is equal to tan of 2 pi over 3. So this guy is kind of, that goes without saying. Because tan of 2 pi over 3, that should be, wait, tan of 2 pi over 3. Wait, is it possible? Tan of 2 pi over 3, that's going to be negative root 3 over, that's going to be negative root 3. So that's the first case. For what value of m is this guy true? Let's quickly sketch this out. We have a v for the asymptote at 1. Putting 0, then we get 1 over here, so it's going to go up. That's going to go like that. Okay. Would it work? Yeah. Wait, 1 over x. X gets. Oh. Yeah, that works. All right, so if it is greater than 0, that means that m has to be less than 1. Yeah, considering we're all dead. Maybe we should come back to this later. Yeah, no, my brain is semi-fried right now as well. Negative 1 over m minus. Right, yeah, this is positive and yeah, I think I'm gonna call it a day.